Antoine? Antoine?
Yes, sir.
Oh, go on. With another people, them.
Yeah, are you going in there? In front of red, this one?
I try, if I get some other people, I don't know what happened to them. Let me see. Hello? You're not logging into class? All right. All right, Antoine, let's go. Let's do this. I guess it is recorded so that other people can watch it. So I have to, well, I'm not going to do the question that we did already in the class, right? Like, for example, this one. Right? Antoine? Hello? What's that man here? Antoine? I'll put about the clock because I'm not seeing anything. I'll put about the clock. I don't know what happened to these students. Antoine, I was about to start, but I'm not hearing you.
Sir, the Wi-Fi did chop out for a while.
All right. I'm start back now then.
All right.
All right. So I was saying that questions on this that we did already. I'm not gonna redo them because they would be on the other video from yesterday's class. All right, so I'm not gonna redo the ones that we did already. So I'm not gonna do this one. We did this one yesterday. And we did this one yesterday. All right, so this one actually becomes -1. This one. So we did that one yesterday as well. So I'm gonna start with this one. Let's start with that one. So I'm starting with 3 to the 2x minus 3 to the 2 minus 2x equals 8. Oh, with the -4 here means divide. So it's 3 to the 2x minus 3 squared over 3 to the 2x minus 8 equals 0. So we can multiply by 3 to the 2x to get rid of that fraction. Multiply through by 3 to the 2x. And this becomes 3 to the 2x all squared. This becomes minus 8 times 3 to the x. 3 to the 2x. And it becomes a minus 9 because this is cancelled and 3 squared is 9 equals 0. Factors of 9 with the difference is 8 is 1 and 9. 1 and 9. So this factorizes into 3 to the 2x, 3 to the 2x, 1 and 9. Signs are different, you get on the minus sign. So minus here plus here equals 0. This is saying 3 to the 2x equals -1 or 3 to the 2x equals 9. So this one is not going to be valid. Because a positive number raised to a power cannot be negative. So this one is not valid. And then this 9 is same as 3 squared. So we can written as same base on both sides. So it's 3 to the 2x equals 3 squared, which means that 2x equals 2.
Yeah.
X equals 1.
Sure.
That is, yeah?
This is you don't mind going through that again from
Huh?
you don't mind going through that again.
Right, this question?
Yes, sir.
Okay, remember, just remember it's recorded there. The
All
session. Which line you think you don't understand?
The how you got rid of the
I mean, from here to here,
yes, sir.
you have to know the laws of indices. You have to know them from left to right and right to left. If I'm going from this to this, is that correct? But when you subtract powers, it's because you're dividing. That's all.
Yes, sir.
You have to know the laws from left to right. You can't do this thing unless you know the laws like the back of your hand. No matter how much time you do it, you have to know the laws. Right? So we know say a to the x divided by a to the y is the same as a to the x minus y. You have to know the law this way, and you have to know the law that way. This a to the x divided by a to the y is the same as a to the x over a to the y. It's still equal to a to the x minus y. Right? So then give me one minus power up here, so in the question. So I'm going to say it's equal to this to this. The minus means divided by 3 to the 2x. That's it. Because you have to know the laws from left to right and from right to left. You have to know if you break this up to get that. Using the laws of logs. You cannot do logs and indices, laws of indices. You can't do logs and indices unless you first know the laws from left to right and right to left. These things will give you problems if you don't know the laws like that. They're not difficult, but you have to learn the laws. You get me? So, if anything, you watch over the video, it is recorded. All right, so this equals that using this law. All right, so that finishes that question. We'll jump into this now. So the front down. These two we did in the class already. We did them in the class yesterday, so they are in the video from yesterday. I'm going to do this one now to rationalize the denominator. Easy stuff. Easy stuff. Rationalize the denominator. So give me. Hold on a second, guys. Marvelous damage. All right. Right. So they give me give us 1 plus root 3 over root 3 minus 1. To rationalize the denominator. I'll put this in the same order of that as that in terms of having the surds in front. So it's the same as root 3 plus 1 over root 3 minus 1. The same thing. I'll switch around these values so that they have the same order in terms of the surds part and the real and the rational part and irrational part. I'm going to multiply this now. Make the denominator rational by multiply by the conjugate, which is root 3 plus 1. So multiply the numerator by the same thing, root 3 plus 1. So the numerator becomes a perfect square, and the denominator is the difference of 2 squares. So this then becomes equal to root 3 plus 1 all squared over the denominator becomes root 3 squared plus 1 squared. Meter my please. Minus 1 squared. Then we expand this perfect square. We get root 3 squared is 3. Then twice product of these things give me plus 2 root 3. And this term squared is 1 over root 3 squared is 3 minus 1 squared is 1. That reduces to 3 and 1 is 4 over this becomes a 2. And each of these can be divided by the 2. So it reduces then to 2 plus root 3. That is the answer. Rationalized. 2 plus root 3. All right. Next question is this one. It says, write x in terms of m and n. In other words, what I want to do is take this and make it become an indices with base 2. Simple as that. All right, so we're going to start with the left side of that expression. And remember, this means root, and this means power. This 4 can be brought to base 2. So I'm going to write it like this first. 2 times 2 to the 2m raised to the power 1 over n. This is root. Can be written as 1 over n as a power. Then this is 2 to the 1 right here. When I multiply them, it becomes, I add the power. So I get 2 to the 1 plus 2m all raised to the 1 over n, not 6, 1 over n. And then I need to multiply these. So it becomes 2 to the 1 plus 2m over n. So therefore x equals this. This is x. That is the x. X equals that. Simple stuff, simple indices. Very simple. That one done. I never realized this paper was so easy. We'll come to this. We did this question already, you know. Because I already did yesterday, it had values, but let's do it again still. Let's do this one again. I think I changed it up a little bit. So let's do it again. So this one first, we're gonna get a Cartesian equation out of it. So I'm gonna write it as 3 to the x equals 9 squared bracket. Then this 27 is 3 cubed. And the cube times y is 3y. So I get 3.
So the 9 squared is supposed to be 3 squared.
3 squared. So I get 3 to the 3y. 3 to the 3y. That's it now. That's it now.
Yes, sir.
And then I have to add these powers. So I get 3 to the x equals 3 to the 2 plus 3y. So therefore, this the powers equal. So we can write that therefore x equals 2 plus 3y. That's our first equation. We're going to get the second equation from this one. So we're going to take this 2 and move it up here as a power. First, we're going to get log to base 2. Let's go back for the red. Log to base 2 of 7. Because this come up here, so I'm going to come a square. Root 7 square is 7. Minus log to base 2 of 11y minus 2x. That's all equal to 1. When you subtract the divide the logs, right? It's become log to base 2 of 7 over 11y minus 2x equals 1. When log of a number equals 1, it means that the base and the number equal. So them two are equal. Those two are equal because the log equals 1. So we can write 7 over 11y minus 2x is equal to 2. We can take this now and multiply it up here by the 2. So we get 7 equals 22y minus 4x. That's our second equation. What we can do now, we can substitute this now right down here for the x. Substitute for the x. So we're gonna get, you can say therefore 7 equals 22y minus 4 times, and the x now is 2 plus 3y. So 7 equals 22y minus 8 plus, not plus, minus 12y. And this is 10y. This negative 7 come away, add to that 7, negative 8, add to 7, give me 15. So y equals 1.5. Now that y equals 1.5, we can substitute it in the x equation up here. Right there. For the y. So we're gonna get x equals 2 plus 3 times 1.5. This is 4.5 and 2, give me 6.5. So we get x equals 6.5. So these are answers. That finishes that question. And now come to the last one down here. This one, which is 5 to the x plus 1 equals 7 to the x. To get the x out of the power, you have to take logs. Pure math, we're going to take log to base e. And so, which is ln. So we're going to take ln of this side and ln of that side. This power comes to the front as a whole power. X plus 1 as one whole thing. X plus 1 times the log of 5. That's what we get when the power comes to the front equals, and this x also comes to the front. So we get x log of 7. We're trying to find the x, and we're going to expand this and get x log of 5 plus log of 5 equals x log of 7. Then we can take this over here and subtract and get the log of 5 equals x log of 7 minus x log of 5. Yeah, factorize the x out of these two terms. log of 7 minus log of 5 equals log of 5. And we take all of this now and divide it on the year. Leave x as a subject. X equals log of 5 over the log of 7 minus the log of 5. That is it. Nice and easy. You can work this out with the calculator if you want. But that is it.
4.78.
All right, so I jump on some past papers now. Couple past papers. I think we exhaust the pure maths ones that we have. The recent year one from 2012 to 2023. We exhaust the pure maths that we have. I think we have one more to do. And 2017 that we didn't do. Let's look for it. 2017. See it here. All right, and we're gonna look into some. We're gonna do some of the AdMaths past papers. And there's nothing left really. So we're really going on to a new topic on Tuesday. These things don't need no more time. Just need to practice what we have done. That's all it needs. Practice what we have done. So it's a similar question to one that we did yesterday. Very similar. Given that this equals that, prove that this equals that. So starting with this as the left-hand side, I must prove the right-hand side from it. Using these things, we have to use this. All right, so start with the left-hand side. So the left-hand side is equal to ln a plus b over 4. All right. Now, they tell me to use this. That is to generate the square. I also see this half in the answer. So what I'm going to do, I'm going to multiply this by a half and multiply it back by a 2. And then the 2 going to come up here and form a power. I'm going to move the 2. So this becomes half ln a plus b over 4 squared. This 2 come up here, so I'm going to form this square right here. I'm going to expand this now. I want to get half ln bracket. I'm going to get a squared plus 2ab plus b squared all over 4 is 16. The question said the sum of these two is 14ab. So this and this is 14ab. 14ab plus 2ab is 16ab. So we get half ln 16ab over 16. 16 cancel, and so you get half ln ab. Well, half ln ab. Ln ab is the same as ln a plus ln b. That's what they told us to prove. Let me see. Yes, see there. Done. That's it. But I said that.
Yes, sir.
All right. Now, guys, notice 2 weeks, 2 topics. When we introduce the Sunday program, it means that we're going to be carrying 2 topics simultaneously. One from the Tuesday, Friday class and one from the Sunday class. Can't allow these topics to pile up on you. Because we're moving on. We're moving on. So you have to make sure you understand these things, this topic, before we move on to the next one. Otherwise, you're going to get left behind. It's going to be a case where you have topics that you don't know, don't understand. I say we only need 1 week for a topic. Generally speaking, in pure maths and AdMaths, 2 weeks the most you spend on a topic. All right, 2 weeks the most you spend on a topic. We generally move fast, so be prepared for that. So anyway, this paper don't know. We exhaust the pure maths papers. Let's jump into the add maths. What is there in add maths? Let's see. Can we look at the paper 3? Let's look at the paper 3. That's certain interesting questions on the pure maths paper 3. Let's go. We might have a couple of paper 3s here. 2016 paper 3. Let's see if there's certain interesting logs on it. Let's see. Nope. Nothing. That's an equation, one of those equations, quadratic. Let me run through this one. So this is minus, go to the minus x, no problem. This can be raised to base 4. So I'm going to write it as 1 minus 7 times 4 to the minus x plus this one, because the 16 is 4 squared. The 16 is 4 squared. I'm going to write this one as 6 times 4 to the minus x all squared equals 0. So I'm going to write this as 4 to the minus x instead. 4 to the minus x. Understand that, guys? Understand that?
Yes, sir.
Huh?
Yes, sir.
All right. So it becomes a quadratic in 4 to the minus x. You can make the substitution if you want to say y equals 4 to the minus x. So the equation becomes 1 minus 7y plus 6y squared equals 0. So if you factorize this, you 1 on 1, you're going to get 6y and y. This makes it 6y, this makes it 1y, give me the 7. Signs are the same, they are both negative. Negative, negative equals 0. Yep. So this one give me y equals 1. This one give me y equals 1 over 6. But the y is this. So I'm now getting 4 to the minus 1. 4 to the minus x, sorry. Equals 1. I'm getting 4 to the minus x equals 1 over 6. But 4 to the minus x is the same as 1 over 4 to the x equals 1. And this one is 1 over 4 to the x equals 1 over 6. So from here now, you say that 4 to the x is actually equal to 1. And from this one, 4 to the x is equal to 6. 4 to the 1 is equal to 1. The next must be 0. Because any number raised to the power 1 is 0. And then this one, we have to take logs of both sides. So here we get ln 4 to the x equals ln 6. X comes to the front right there. So x ln 4 equals ln 6. Divided by the ln 4. X equals ln 6 over ln 4. So those are the answers for this question. Alright. This is that. See if the logs there is still. That's a proof. Done. No logs. No logs, that's traits. It's a paper 3, guys. You got another one. Let's see if there's any on this 2018. That's a proof. It's a logs. So I use the base is X, like this. This base is X and this one. No matter, still apply the rules. When the base is the same, adding logs become the log of the product of the same base. So this becomes the log to base X of this times 4. Multiply them. When I multiply them, it becomes 4 times all of that. The 4 2 is 8 and the 4 3 is 12. So I'm gonna get 8x minus 12. All of that equals 2. So this number equal this base raised to that power. So it works, you know. The number equal the base x raised to the power 2. So we have 8x minus 12 equals the x raised to the power 2. So it becomes a quadratic. I'll take these and multiply them over here. Transpose them on this, sorry. I get x squared minus 8x plus 12 equals 0. Factor of 12 that add to 8 is 6 and 2. So I'm going to factorize this. X and 2 and 6. Two signs are the same. They are both negative. Negative, negative. So we get x equals 2 from this. X equals 6 from that. Let's try the values now. If I plug 2 here, so it's going to be okay. That works. If I plug 6 here, so it's going to be okay. And basically, that is it. Those are my answers. Any questions on that?
No, sir.
It is straightforward, yeah. It is straightforward. I think that's it. Yes, and there's one more paper there. So all you need to do, guys, is read all these questions. That's all you need to do. Paper is this. All right, let's see. On the first question. On the first question we're gonna do. The rest of it is log, Surds, and Indices. The first one is a Surds, this guy's quadratic equation. Easy. E, say telling us to use y equals e to the x. Telling us that. This is the same as e to the x squared minus 21 e to the x minus 100 equals 0. Same as y squared minus 21y minus 100 equals 0. Difference of 100 that is 21 is what? This difference of 100 what factor of 100, the difference is 21. What are those?
25 and 4.
25 and 4. Good. So factorize this. Y and y, 25 and 4. Signs are different. Greater product of minus. Greater product of minus this plus equals 0. So y equals 25 or y equals -4. Why is this? So it means e to the x equals 25, e to the x equals -4. Now remember, e is a positive number, you know. So this one is not valid. A positive number raised to a power cannot be negative, so this one is not valid. So it's having this one, where you do take ln of both sides. So I'm going to take ln e to the x equals ln 25. This x comes to the front, and so I get x ln e equals ln 25. But ln e is equal to 1, for ln is log to base e now. So this is equal to 1. So x equals that. And that is it. All right, that finishes that. So let's look at the AddMaths, see if there's anything interesting in AddMaths. It's the same level, really. So logs and indices. Let's start with the most recent paper that I have here, which is this one. 2013, somewhere in the 2023, somewhere in there. You know what? Let's start with that one. Let's see, 2022. Stand them easy, you know. Let's see. Surds, logs, and indices. If there are any here. So far, no. So some surds right here, so show that this equals that. That's what I'm supposed to do. Hold on a second, guys. Fix my pen. And I show that those two things equal. Now first, the root of 25 is 5 right here. That's the first thing. So clearly, the diameter is rational. First, I'm going to write it as 5 over root. A perfect square, that is 9. I'm going to put 9 times 5. And this is 3. So it becomes 5 over 3 root 5. I don't want no root under here. I'm going to rationalize it. Multiply the numerator by root 5 and the denominator by root 5. So these two give me 5. So that becomes equal to 5 root 5 over 3 times 5. Root 5 times root 5 is 5. Then this 5 cancels this 5. So the final result is root 5 over 3. Easy stuff. Simplifying surds. I don't think there's anything else really. Let's see, might be another question. Logs. Let's see. Let's see. Okay, that's it. Differentiation and stuff. That's it, you know. None in 2022. Let's go on 2021 and see. 2021. Let's see what they put on 2021. 21 is a polynomial, it's a quadratic, that's a function. Here's a log. Given those things, find the value of a. Now, first thing, this equal 1. And the log of 10 is 1. That's the first thing. This equals 1. Log of 10 is 1. So, and then this minus means that I take the log of the quotient, right? So this expression becomes the log to base 2 of 6 plus root 12 over 3 plus root a equals 2 equals 1 equals this one. Log of 10 is 1. So this number is equal to 2 raised to the power 1. So 6 plus root 12 over 3 plus root a is equal to 2. Equal to 2, which is really 2 to the power 1. Then this base going to multiply across here with the 2. And so I'm going to get 6 plus root 12 equals 6 plus 2 root a. So the 6 them cancel. And then this 4, this 12 is same as root 4 times 3 equals 2 root a. So the root of 4 is 2. So it's become 2 root 3 equals 2 root a, which means that a equals 3 right there. Easy. Which means that a is equal to 3. That's the answer. Any questions on that? Easy, right? Hello?
Yes, yes.
Very easy.
Yes, sir.
I don't think I want to do anymore. Let's see this one. This is see these are indices. This is positive let's start with some GP, geometry progression. It's more indices question about because it's common at GP. Maybe I do GP, we'll do that one as well. So I'm gonna leave that one. All right, let's look at 2019. Because there was none in 2020. Let's look at 2019. Questions we have exhausted the question. I think they're very easy. That easy one here. All right, so I want us to solve this for x. I can literally carry up. I can carry up the arm. I can carry up the tree to trace and put as a power, you know, and get it as log of 2 to the 3x plus log of a to the x equals 2. This now is same as that 2 cubed to the x, which then becomes the log of a to the x plus the log of a to the x equals 1, equals 2, sorry. Then there are 2 of them here. So we get 2 times the log of a to the x equals 2. So the 2's cancel on either side of that. And so we get the log of a to the x equals 1. Remember, this is base 10, you know, LG means base 10. I'll put another way, you can move the x to the front. All right, move the x to the front. And let's not complicate it. X log of 8 equals 1. So you divide by log of 8, x equals 1 over the log of 8. That is the answer right there. What I go to that?
Yes, sir.
All right, I don't think these questions posing any challenge, so this question is really very easy, really very easy. Let's look at 2018. We exhausted the pure maths ones, and now we're just, looking for the hard maths. I think about it, there's nobody here in this group now doing hard maths. Like this don't make any sense. How we're doing now? Nobody in this class now doing pure maths, this group right here. I think I'm gonna stop it there after this, guys, because no make any sense. Them questions are, you're not learning anything from these questions. Surds, logs, and indices. I'm gonna stop it after this one, after the next one. Don't make any sense at all. It's too easy. Let's do something more meaningful next class. Which was that we looked at? 18, 17. Let's do one more. We will find out one more, we'll call it a day. Because the main thing was to go through the work that I sent yesterday, which I did. That was the main objective of this session, really. And to finish out the past papers, but we'll finish them done. I'm just saying and listening. Done. 2016. This guy's equation here. Let's focus on the logs. This one. Let's finish off these two and we'll call it a day. That's, it's ridiculous. This one says we have to make C the subject. C. All right, first thing I'm going to do, I want to get this here to be my subject. I'm going to move away this K first, divide it on the here. So I'm going to get T over K equals P to the H over C. Then I'm going to take logs of both sides. I'm going to get log of T over K equal to log of H over C. Now this H over C is the same as 1 over C times H, I'm going to move the 1 over C to the front and leave the H. So move the 1 over C to the front. I'm going to get the log of T over K.
So what happened to the P? So what happened to the P?
Long thing. I need to put the log in front of it. Log of P. I just need to put log in front. Don't mind me. All right, so I'm going to move it 1 over c to the front. So from 1 over c, the log of p to the log of p to the h. P to the h. And then now, I want to make this a subject. I simply multiply it up and divide everything under here. So the c becomes the log of p to the h divided by the log of t over k. That's it. C is my subject. Understand that?
Wait, so can you work from the second line again, please?
You mean from here?
Yeah.
And this will get this 1 over c.
Mm-hmm.
All right. All right. Because this h over c, you can write this as the log of t over k equals the log of p to the 1 over c times h. See that?
Yes, sir.
I can move the 1 over c. You see alone, I'm interested in becoming the subject, you know, so I can move the 1 over c alone. I'm free to do that and leave the p to the h. So I write it as the log of t over k equals 1 over c log of p, and this h remains on the power now to the h. And then from here now, I can multiply the c and take all of this and divide it under the log of p to the h. So I do my final line up here. The c becomes equal to log of p to the h over the log of t over k. Better?
Yes, sir.
All right, good. All right, so this one now. I feel a little bit drowsy, guys, because I have to take some medication today because I'm coming down a little bit. I'm coming down with a little sniffer, so.
Yes, sir. I heard the coughing.
Yeah, I took some multi-symptoms, so it made me a little bit drowsy. So I'm going to apply the laws of logs to this one. I'm going to multiply these. So this becomes the log of the product. X plus 1 times x minus 1. And these two come up here as a power. So it becomes the log of x plus 2 all squared. So since we have the log of this equal the log of that, okay, this becomes the difference of 2 squares, you know. This is the difference of 2 squares. So this is the x will become the log of x squared minus 1. It's a perfect square, which is the log of x squared plus 4x plus 4. If you expand it, so it means that this equals that. We drop the logs. This means that x squared minus 1 is equal to x squared plus 4x plus 4. So these cancel each other. The x squared terms cancel each other. And so I can transpose the 1 over there and add it to that and get 0 equals 4x plus 5. Therefore, x equals minus 5 over 4. That is it. That is it. All right, guys, I think I'm going to stop it there. That's all I have question left. Moving on to a new topic. Tell you what topic we're doing next. I think we might introduce the pyramid class next week. Start the pyramid class. I'll let you know. Start the pyramids. Not going to wait much longer to start it. Everybody fully up and running in school now. So it makes sense. All right, so the next topic is coordinate geometry. So we're gonna do coordinate geometry of lines. First, we really want to do coordinate geometry of circles, and it's the same thing in pure maths and odd maths, another topic. That's the same in odd maths and pure maths. Equation of a circle, tangent and normal and so on. Same thing. You look at the odd maths paper, you look at the pure maths paper, the questions asking the same thing. Just that the odd maths questions tend to be a little bit less than the pure maths questions. All right, but it's the same thing. Center point, complete the square. So those who do odd maths already, you should have a very super easy time doing equations of circle. So we're going to focus on the lines first because you have to understand lines before you can get to circle. So this topic is going to take us 2 weeks. So we're going to do first week going to be lines, focusing on lines. And then the second week we're going to be focusing on the circles, putting it all together. And the association relationship between the lines and the circle. All right, so that's what we're going to be doing next, starting Tuesday. As I said, we might start the Sunday program next week. But when we start the Sunday program, remember that you'll be carrying 2 topics simultaneously. You'll be carrying 2 topics simultaneously because the pure maths topics, straight pure maths topics, will be done on a Sunday. And it's not like we're breaking what we're doing Tuesday, Friday. We're continuing with the Tuesday, Friday content along with the Sunday content. So we'll be carrying 2 topics at a time. All right, guys, so that is it. See you all on Tuesday. I'll send the video and I'm done, even though I doubt there's much to begin from these. Believe me, that is so easy, ridiculously easy. Don't make any sense. So it's turned out to be a 1-hour session, but that's fine. That's okay. All right, so see you all on Tuesday.
Later, sir.
Bye.
All right, bye-bye.
Bye, Dad.
Bye, Kai. Later.